Good evening, miss. Good evening. Because UPSC results are out, you might have heard. My own students with geography optional have scored 480 and 795. Yes. So, guys, I wish you people must also be in the list. Okay. Yesterday there was some technical issue, guys. Actually, we could not log in. That was a problem. Byju's will update it, guys. This is from my side. Byju's will update you. Okay. Yeah, ma'am. Yesterday class was not there. Extremely sorry for that. Actually, there my what do you call us? It was not logging in yesterday. We tried for almost 45 minutes. Okay, shall we start? Shall we start? Yes. Yes. Is it echoing for everyone? Is it echoing? Okay. Okay. Everyone, I was talking to you people with respect to seismograph. I told you people that there will be like this. Okay. The first one which appears is known as P waves. The second one which appears is known as S waves. And the third one which appears is known as surface waves. Surface waves. Okay. So, why we want to know this is if we can understand the P waves and S waves, we can basically understand what is there inside the earth is. Because P and S waves travel throughout the earth. Now, what we did, we started studying P and S waves. So, to study P and S waves, guys, we actually took rocks at different places. Okay. And we saw how exactly the rock has been modified. Now, when I observed that, what I found was in some areas, in some areas, the rock was compressed like this, and in some areas, the rocks had expanded. You see, the rock has compressed, the rock has expanded, rock has compressed, rock has expanded. Now they started analyzing where exactly will you find it. Now can you see this? Here the waves are compressing, expanding. Okay, rarefaction we call. Compression, rarefaction. Compression, rarefaction. You see, in this particular part, we will observe that there is compression, there is rarefaction. There is compression, there is rarefaction. There is compression, there is rarefaction. You see here, guys, compression, rarefaction, compression, rarefaction. This is there. Check here. Compression. rarefaction. Can you see here? All particles are closer. Here particles are far from each other. Particles are closer, particles are far from each other. Okay. Now, based on this, I will try to tell you what is the characteristics of these p waves. So, the first characteristic that you must be aware is p waves. P waves travel in the form of p waves travel in the form of compression and rarefaction. P waves travel in the form of compression rarefaction. That is, guess if any waves travel like this, that is, it is similar to what? Longitudinal waves. If anything travels in the form of compression and rarefaction, it is called as longitudinal waves. Okay, ma'am. Okay. Second, guys, the beauty of P waves is P waves can travel in solids, liquids, and gases. So P waves can travel in all the three. It can be solids, liquids, gases. But remember, the P waves property is, if you take iron, if you take wood, guys, can you tell whose density is more? Iron, wood. Whose density is more? Iron density is always more. The meaning of density is, guys, in iron, particles are closer to each other. Particles are closer to each other. In wood, particles are far from each other. Far from each other. Okay, guys, you tell me, when a wave has to go, okay, if particles are closer, compression rarefaction is easier. Okay, if particles are far from each other, compression rarefaction will be slower. So basically we try to say that when density is more, when density is more, speed of p waves is more. Speed of p waves is more. Okay. If density is less, then speed of p waves is less. Okay. Yes, Anjali. Longitudinal waves are mechanical waves. Fourth is, yes, ma'am. When density is more, compression rarefaction is faster. Okay, because particles are available closer. Everyone see here. Can I say this is how the particles will move? This is how the particles will be there? Guys, if I say this is direction of p waves, direction of p waves, okay, particle is also compressing, you see here, compression rarefaction. Compression rarefaction. Can you people tell me? Can you people think and tell me now? Is this compression rarefaction occurring parallel to wave movement, or is it occurring perpendicular to wave movement? You see, the direction is this, compression rarefaction is also occurring in the same. Okay, so we say particles vibrate parallel to wave movement. Particles will vibrate parallel to wave movement. Everyone, did you write till here? Particles vibrate parallel to wave movement. Okay. See here, guys. Particles vibrate along the direction of propagation of the wave or parallel to. Okay. They travel both in solids and liquids. Speed is more in solids, slow in liquids. I told you as density decreases, speed also decreases. Denser the substance, faster the movement, because material availability is present continuously. Even in liquid molecules, materials are present, so P waves travel. And example for P waves is sound waves. Example for P waves is sound waves. Now everyone, gases also, gases also, Chandru, because in gases also we have particles, but it will be slowest. Everyone, for 2 minutes, observe carefully. No need to write this. This is only for your understanding, guys. Let me say there is a building here, guys. Okay, there is a building here. Now, if you look at here, let me say this is the focus, guys. This is the focus. So, guys, energy P wave is traveling in this direction. P waves is traveling in this direction. You will have compression, rarefaction. Compression, rarefaction. So, what will you have? You will have compression, you will have rarefaction. You will have compression, you will have rarefaction. Can you tell how the building will move, everyone? Can you tell how the building will move? Will the building move up and down, or will the building move sideways? Will the building move up and down? You see, if you keep the building on a spring, okay, if you keep the building on a spring, how will it go? Correct? Up and down. Okay, so you will have up and down. Okay, now we will have S waves, or it is secondary waves. S waves or secondary waves. Everyone for 2 minutes understand this carefully. S waves or secondary waves. Okay. Now these secondary waves, let us say I will tap the water. Okay, bucket filled with water, I will tap. So what will happen? You will have waves generated on both the sides. Similarly, whenever there is S waves, we normally observe that there will be some sort of waves generated. Okay, guys, everyone, you tell me if this is direction of S waves, if this is direction of S waves, can we say that in this case the S waves is actually moving? Can you tell me how the particles are vibrating, guys? So for the direction, the particles are, first point, particles vibrate perpendicular to wave movement, perpendicular to wave movement. This is the first point you all must be aware about this. Okay, this is the first point you all must be aware about. Particles vibrate perpendicular to wave movement. Second, guys, here also you see this is how it moves. Guys, for this, okay, if it is solid, and if you take liquid, okay, S waves can travel in solids, guys. S waves can travel in solids. That means when I look at the solid particles, within solid particles, S waves keep on moving. Okay? S waves keep on moving within the solid particles. But when it is liquid, can you see gap is there? In liquid, gap will be there. Because of the gap, actually S waves cannot travel. So we normally say that S waves can travel in solids, but not in liquids or gases. S waves can travel in solids, but it cannot travel in liquids or gases. Yeah, Kamalpal, yes. No, not. Okay, okay. You see, guys. Uh, you take a solid object. Okay, you take a solid object. Can I say in the solid object particles are closer? Particles are continuously available. Vinod, Aditya, and all. Yes. Is the particles continuously available? If particles are continuously available, S waves can travel easily. But in gases, can I say particles are far from each other? Liquids, can I say particles are little far from each other? So normally what happens, as soon as S waves enters into liquid medium, you will not have S waves at all. Okay, yes, it disappears. Next, guys, you tell me, guys, if particles are closer, will S waves move faster? If particles are closer, will S waves move faster? If particles are far from each other, can I say it will be slower? Yes. So guys, please everyone look at this. S waves are faster in denser medium, and it is slower in lighter medium. Everyone, even if concept is different, I want you people to remember two things. S waves can travel only in solids. P waves can travel in solids, liquids, gases. Both P and S waves, how do they work? Both P and S waves travel faster in denser medium, slower in lighter medium. This is what you normally observe. Yes. Yes. Well, next is, how do S waves travel? S waves travel in the form of crust and trough. Do you all agree? Crust and trough. That is like transverse waves. P waves are called as longitudinal waves. S waves are called as transverse waves. Yes, Aditya. Ma'am, we use the term transverse, ma'am, rather than mechanical, non-mechanical. Is this done? Is this done? Yes. See here. Particles move at right angles to the waves. Do not pass through liquids, water, ripples, or light waves. Now everyone, think and tell this, okay? See properly, this is not for writing, only for your understanding. Okay. Here, can I say you have focus or hypocenter? You have focus or hypocenter, okay? Now wave is coming till here. Huh. Can I say the particle vibration will be sideways, guys? Yes or no? Can you tell how the building will shake? Will the building shake like, right, left, or will it shake up and down? Sideways. Very good. Guys, can you tell P waves, how does it travel? How does it travel? What does it do to the building? P waves up and down. Everyone, P waves up and down. Okay. S waves side. Everyone see this for a minute. First, P waves will go up and down. Second, S waves will push right and left. So initially when P waves will come, building will go like this. Second, when S waves will come, building will go like this. Third, both P and S waves will join. You see, when P and S waves join, P waves up, S wave side, P waves down, S waves bring back. Up, side, down, again it brings back. You see here, fraction of second if you check. Yes, can I say it is elliptical? Can I say it is elliptical? Do you all recollect whenever there is earthquake, building shakes? Do you all recollect whenever it is there, building shakes? Yes, yes. See guys, surface waves, first, they are combination of P and S waves. Do you agree? They are combination of P and S waves. Second, they originate near the surface. They originate near the surface. Near the surface. Okay. Yes, you tell me, if Nepal has earthquake, okay, if Nepal has earthquake, places closer to Nepal, will it have some impact? Places closer to Nepal, will it have some impact? Yes. Places little bit far from Nepal, can I say impact reduces? Impact reduces. And as we move away, can we say impact keeps on reducing? Impact keeps on reducing. So what do you say? What do you say? Surface waves impact reduces from epicenter outwards. Do you all agree with me? Reduces from epicenter outwards. Okay. Guys, what is the shape of rotation, guys? What is the shape of particle vibration? You see, surface waves are divided into two types. One is Rayleigh waves. Rayleigh waves. It is also called as R waves. Okay, R waves. R waves movement is elliptical. R waves movement is elliptical. Very good. Everyone, please see here. Please see here. P waves, S waves. P waves, S waves. Right? Let us say the impact is very high. Okay, impact is very high. You tell me, if impact is very high, is there time for building to go like this, come like this, or will it move like this? You tell me, will it go elliptical, or if impact is more, if earthquake intensity is more, can I say the building will shake like? Whenever the building shakes like that, it is called as love waves. We normally call it as L waves. And in L waves, normally the movement is zigzag. Okay, in L waves, the movement is zigzag. Okay, now my question to you is, which is the most destructive waves, guys? P, S, R, L. Can you tell which is the more destructive? Which is more shaking? Which is more shaking? Which is more shaking? Among the four, you should choose one. Love waves are the most dangerous waves. Love waves are the most dangerous ones because the buildings are literally shaking in zigzag form. Now, I hope this is easy to remember, right? Is this easy to remember? Because which third point, Chandru? Which third point? Yeah, surface waves once. No, Aditya. You see, P waves will push upward. S waves will push it sideward. P waves bring it down. S waves brings it back. Okay. P S P S. This is called as what? Surface waves. Now, whenever surface waves is of two types. When impact is less, it will be like this. Okay, elliptical. It is called Rayleigh. If impact is very high, you will have zigzag like this. So, whenever earthquake intensity is more, it will be low waves. If earthquake intensity is little less, you will have Rayleigh waves. So, the most dangerous one is the low waves. Okay, the most dangerous one is the low waves. Yeah, just remember one simple thing. Love is always dangerous. Never enter into it. That's why they named it as that. Yeah. It is also problematic in college life, UPSC life, everywhere. Name itself says it is dangerous. Be careful. Yeah. I can see so many people are happy, experienced it already. Anyways, yeah. Gautika, if you check epicenter, okay? See this. If we take epicenter, near the epicenter, impact will be more. Impact is more. But as we move away from the epicenter, the impact keeps on reducing. Ma'am, it is similar to sound waves, ma'am. That is, as we keep moving forward, as we keep moving away, can I say the impact of sound reduces? Similarly, the wave impact also reduces as we move away. P waves also reduces, S waves also reduces, ma'am. S waves example is light waves. Kamalpal, don't worry about it. Yeah. Manpreet, no. Vinay, no need. No need. Kavita, I told from the epicenter, if you are moving outwards, impact keeps on reducing. Okay. Reduces from epicenter outwards. Zigzag, ma'am. Zigzag. Okay, everyone, shall we move? You see, arrive after body waves on seismograph. They start from epicenter. See this. How do we know that something is surface waves or not? Okay. Initially on the seismograph, first thing you get is P waves. Second thing you get is S waves. After that, P and S waves will combine and come out. And remember, this surface wave is not present inside the earth, and surface waves are present only near the earth's surface. They travel slower than the body waves, and they are responsible for destruction of the earthquakes. So whenever you say earthquakes have occurred, it is mainly because of surface waves. Okay. Rayleigh waves, love waves. You see, guys, whenever you have Rayleigh waves, the movement will be in this manner. Whenever you have love waves, the rocks will move like this, zigzag fashion. Now, okay, Karthik, earthquake is destructive or not depends upon intensity, Karthik. If more energy is released, then destruction is more. If less energy is released near the focus, okay, in the focus, if more energy is released, you will have more destruction. Less energy is released, less destruction. Fine? Everyone, now, you see. We saw earthquake waves. Now we will try to study interior of the earth waves. Okay, everyone, we will try to study Chandru, body waves will not impact outside. Body waves will impact only inside. Okay. So inside as it travels, we do not find much impact of body waves. So we find impact of body waves only when they come to the surface and join. Everyone, let us talk about interior of the earth waves. Most important topic is we have two topics in this. One is interior of the earth, another one is volcanoes. And then we will have exogenetic. I'll talk about those. Interior of the earth means I want to know about the earth, what is there inside. So, to know what is there inside, I try to go for direct evidences, and I will also try to study indirect evidences. What is the direct evidence that I will have? The first direct evidence that I have is mining. Everyone, you tell me, if I do mining, can I go inside and check what is there inside the earth? Now, when I looked at mining, Kolar Gold Field, KGF, okay, Kolar Gold Field, they went for up to 4 kilometers. Depth wise, KGF, they went till 4 kilometers. But diamond mines of South Africa, diamond mines of South Africa, they went till 6 kilometers. Recently in Russia, they actually went for 12 kilometers. In Russia, they went almost for 12 kilometers, basically near Kola Peninsula. In Kola Peninsula of Russia, they have actually gone for how much? 12 kilometers. Okay, so mining, what is the maximum I have gone? Only till 12 kilometers. From mining, what I understood was continent is made up of silica and aluminium. Ocean is made up of silica and magnesium. And remember, ocean is denser. Ocean is denser compared to continent. Compared to continent. Okay, guys. This I studied from mining, guys. Okay, from mining, what I studied was this. Mariana Trench is 6-7, but that is, we have not gone till the bottom of Mariana Trench, Aditya. We don't know the composition and all. Second, volcano. Guys, you tell me, from volcano, can I expect lava flow? Can I expect lava flow? And you tell me, is this lava coming from asthenosphere? Everyone, is this lava coming from asthenosphere? So can I say volcano helps us to know composition of asthenosphere? Composition of asthenosphere. Ocean is denser compared to continent, Madhu. Okay. Guys, after this, we will go for indirect evidences. Indirect evidences. Okay. First one. First one. Gravitational force. Guys, everyone, you tell me, where do you have more gravitational force? Where do you have less gravitational force? Gravitational force, where is it more? Where is it less? Can I say near equator gravitational force is less, and near poles gravitational force is more? Gravitational force is less, gravitational force is more. Can you people please tell me what is the reason for this? What is the reason for this? Can I say pole is closer to the center of the earth and equator is far? Yes. So we normally say that, okay, everyone write along with me, as, okay, as earth is in geoid shape, as earth is in geoid shape, we normally observe, we normally observe as earth is in geoid shape, we normally observe that equator is far from the center of the earth, center of the earth, and poles are, and poles are closer. Due to this, gravitational force is maximum near poles and minimum near equator. This proves that center of the earth is made up of high density material. Okay guys, this is very, very important for us. Okay, next you see here, second one. Yes, Aditya, that is the indication. Second, geomagnetism. Everyone, do you recollect? Geomagnetic field is created because of interaction between inner solid core and outer liquid core. Can I say it is combination of inner solid core and outer liquid core? Okay. Then from geomagnetism, we understand that there is inner solid core and outer liquid core. Guess you tell me, have we seen this or we are assuming based on the evidence? Have we seen this or are we assuming based on the evidence? That is the reason they are called as indirect evidences. Clear? Everyone? Shall I move? Third, meteorite. Ma'am, Kamalpal, if magnetic field has to be there, okay, there must be iron and there must be charged particles going around it. And that is possible only when there is a solid medium and a liquid medium. So this is an assumption. Okay. Second, gravitational force. I am experiencing maximum near poles, minimum near equator. I am assuming that center of the earth is responsible for that. It may be correct, it might not be correct. Meteorite. You tell me, if entire solar system is made up of similar material, then can I say earth and other objects in the solar system are also made up of similar material? Okay, you tell me, if entire solar system is made up of similar material, then Earth and other objects in the solar system are also made up of similar material. So then you see, if I study meteoroid, is there a possibility of me understanding Earth's interior? I'm asking you, I'm not concluding, I'm telling you, is there a possibility? Yes, there is always a possibility. So what exactly is meteoroid? Okay, meteoroid impact. So what do we see here? If we assume that entire solar system is made up of similar material, then Earth and meteoroid should also be made up of similar material. So study of meteoroid study of meteoroid helps in understanding Earth's interior. No, Sony. What I try to tell is Mercury, Venus, all planets in the solar system, meteoroids, asteroids, everything, they're all made up of similar material. As I am not able to go inside and study whatever is present outside, when it comes to Earth, if I take and study them, then I can say Earth is also made up of similar material. So inside the Earth, same minerals may be present. So I just try to get a clarity that it may be similar. That's it. Is this done, everyone? Is this done? Yeah. So now you have fourth one, seismic waves, guys. Seismic waves. Now, what exactly is seismic waves? You see, earthquake waves, earthquake waves, especially body waves, body waves travel throughout, travel throughout the earth, throughout the earth, and help in understanding Earth's interior, helps in understanding Earth's interior. Earth's interior. What is the property of P and S waves, guys? P and S waves. Can I say travel faster in denser medium, and slower in lighter medium, correct? In lighter medium. Next, P waves travel throughout the earth. P waves travel through solids and liquids, whereas S waves travel only through solids. Done, everyone? Everyone, for 5 minutes, everyone, please look at this, okay? Please look at this. Is the glass, I'm telling you again and again, if you don't understand this, next 15 minutes, you won't understand anything. So please look at this carefully. Later, you can write and do whatever you want to do. Look at this glass, guys, okay? Look at this glass. Can you look at the straw? Okay, can you look at the straw? Can you see the straw has bulged in the water? Everyone, can you see the straw has bulged in the water? That means its size has increased. Yes. I want you to check 3 parts here, guys. Can you see here? This is air medium. This is air medium. You see here. This is glass and air medium. And you see this. This is glass and water medium. Okay. Guys, can I say in this image, in different mediums, straw is seen differently? Straw is seen differently? Yes. Everyone, this is called refraction, guys. This is called refraction. Don't ask why. Okay? Don't ask why. Now, you see, if you have only air, can I say the straw look like this? If you have only air, straw looks like this. If you have only water, okay, let's say completely filled with water, straw will be bulged like this. Correct, guys? Only water, straw will be bulged. Now, if I keep the straw, half of it inside and half of it outside, can I say it will be like this? Guys, can I say that as medium changes, can you see there is change in the direction? This process is basically refraction. You tell me now, if it is same, if medium is same throughout, is it straight? If medium is same throughout, is it straight? If medium changes, does it bend? If medium changes, does it bend? Yes. Now you tell, everyone think and tell now. In a simple form, please think and tell. Inside the earth, will you have same or will you have different? Inside the earth, will you have entire earth inside the earth? Will it be same or will it be different? Okay. So some people are telling it is same inside the earth. Some people are telling it is different. Okay. So what we do, we try to see, we try to see shadow zone of P and S waves. Shadow zone of P and S waves. Okay. You see this. Can I say you will have crust? Everyone don't draw, wait for a while. Crust, mantle and core waves. Okay. Everyone see here. Guys, you tell me, when I drew, I got P waves like this. Please tell me, everyone, if I am drawing in a curved manner, does this mean inside the earth you have same medium or different mediums? Inside the earth, do you have same medium or different medium? Basically, curve means inside the earth you will have different medium. And everyone see here, this is my liquid. Okay, this is liquid. Can you tell me P and S waves, do they travel, P waves, do they travel fastly in liquids or slowly in liquids? P waves, do they travel fastly or do they travel slowly? They travel slow. You see, why is it traveling slowly? Because it gets refracted like this. Everyone, please see here. It is getting refracted. As it is getting refracted, can you check here? This is my 0. This is 105 degree. This is 105 degree. This is 140 degree. This is 140 degree. Guys, in between 105 and 140, we will not observe P waves. Okay, as P waves is not visible, it is called as shadow zone of P waves. I just want you to know one thing, guys. If you are traveling in a car, okay, let us say I'm traveling in a car and this is the mirror I have. Okay, I'm traveling in a car and this is the mirror I have. Now, when I am looking at the mirror, I can see whatever is there till here, guys. Okay, whatever is there behind this. But if something is beyond this, it is not visible to me. Whatever is not visible to the mirror, they all come under shadow zone. Okay, yeah. See guys, this 105 to 140. Some books say it is 103 to 145. Some books say 105 to 145. Numbers change, guys, but this is an average. Okay, standard books give you this. Don't worry about the numbers. Everyone. Now, I want you people to think on another aspect, guys. I have Kamalpal 0 to 105, it is refracting. That's why curve. Okay, that's why curve. Guys, S waves, you see? S waves will also travel like this. S waves will also travel like this. Everyone see here? S waves will also travel like this. Can you tell me if this is liquid layer, will S waves travel or it won't travel? It won't travel. So can I say from 105 to 105, you will not see S waves at all. So can I say it is shadow zone of S waves? Can you tell whose shadow zone is more? P wave shadow zone is more or S wave shadow zone is more, guys? P wave shadow zone is more or S wave shadow zone is more? Rajib, P waves is only from 105 to 140 on both sides, whereas S waves is from 105 to 105. Yes. Can you all write heading shadow zone of P and S waves? Shadow zone of P and S waves. Within interior of the earth, Suman. Within interior of the earth. Yeah. Draw this, guys. Draw this. Epicenter, Aditya. No, Aditya. We calculate it from that because we do not know degrees, right? From epicenter, we can't draw exactly. That's why. Yes, Aniket. That is due to this. Shiva, tell me, what is the doubt? Okay. Shiva, P and S waves means P waves means like primary waves. S waves means secondary waves. Are you done? Everyone? Kamalpal, it is inside the earth, Kamalpal. So it's fine if you are not able to imagine what is happening inside the earth. Okay, you have earth, okay. I'll explain in simple form. You have earth. In all these places, I have kept seismograph. Okay, I have got seismograph in all the places. And when I searched, when earthquake occurred, okay, I saw when earthquake occurred. So when earthquake occurred here, I found that everywhere P waves came except in this region. How do I know it is P waves? Because seismograph records P waves. S waves decreases, but P waves and S waves every seismograph records. So seismograph didn't record P waves in between 105 to 140. And seismograph did not record seismic waves from 105 to 105. That means I did not observe seismic waves from 105 to 105. Everyone draw this also. Yes, yes, ma'am. Both. Yes, Aditi. Here, yes. Aditya, yes. Shall I move? I'll take extra, ma'am, if required. Don't worry. You see, guys, this is how it looks like. Okay, this is how you get. You see, P waves in this part you will not have. S waves you will not have from here to here. Now, everyone for 2 minutes, please see carefully, guys. Then I'll explain other parts. Okay. Now, what geographers did? Geographers created artificial earthquakes. Artificial earthquakes by dropping bombs. And then they started analyzing how things are going to work. Now, when they saw that this is 0, this is 35, this is 0, this is 5 kilometer. Everyone, now I want you people to tell. P and S waves are traveling slower in 35 kilometer thick continent compared to 5 kilometer thick oceanic. Can you tell the reason? P and S waves are traveling slower. See, guys, they can calculate time, distance, speed. This can be calculated. Okay, but I'm telling you, Why P and S waves are faster in 5 kilometer thick? I'm not talking about water. I'm talking about 5 kilometer thick oceanic crust. It is moving faster, 35 km slower. Aditi, no Aditi. This is not epicenter. Yeah. Guys, continent is made up of, because continent is made up of silica and aluminium. Ocean is made up of silica and magnesium. And you just read that P and S waves travel faster in denser medium and slower in lighter medium. Do you recollect? Do you recollect? P and S waves travel faster in denser medium, slower in lighter medium. So from that, can I come to conclusion? Can I come to conclusion that continent is lighter, ocean is denser? Then is everyone, you see, till 100 kilometer, till 100 kilometer, we saw upper solid mantle. Everyone, you tell me now. Upper solid mantle is denser. Okay, upper solid mantle is denser compared to continent and ocean. Okay, upper solid mantle is denser compared to continent and ocean. Now you tell, if that is the case, P and S waves, will it be faster here or will it be slower here? Faster. Kennedy, Suman, I don't know why you people miss things. If density is more, it will be faster. Why do you say slow? Kamalpal, that's what I told. In ocean, it moves faster. Continent, it moves slower. Okay, see guys, some people are getting confused. I repeat. Okay, P and S waves, if it moves faster, that means that layer is having high density. If it moves slower, that means that layer will have low density. If there is liquid, only P waves will travel. If there is solid, both P and S waves will travel. So if you have come late, avoid answering the questions rather than answering wrong. If you have not attended the class till now, if you just came, please avoid answering, understand the class rather than giving your own answers. You see guys, till 600 kilometers, everyone, till 600 kilometers, if I have semi-solid layer, which is asthenosphere, you tell me semi-solid density is less. Semi-solid density is less. As density is less, what is going to happen? P and S waves will slow down. P and S waves will slow down. Next is till 2,900 kilometers. Till 2,900 kilometers, we observe lower solid mantle. Till 2,900 kilometer, we will have lower solid mantle. I want you people to tell me, if it is lower solid and its density is more, can I say it will be faster or it will be slower? It will be faster or it will be slower? Faster. Good. Guys, everyone see here, 5,100 kilometer, 5,100 kilometer. Can you people think and tell, if I have outer liquid core, okay, if I say outer liquid core, can you people please tell me in liquids which one will go, which one will not go? Only P waves will go, S waves disappear. S waves disappear. Then you have 6,300. You have inner solid core. Everyone, you tell me, will you have highest speed or will you have lowest speed here? If it is highest density, highest speed, very good. See guys, everyone check here. In between crust and mantle, see guys, in earth we observe crust, mantle. Okay, you see crust, mantle, core. Okay, in earth we find what? Crust, mantle, core. You will have all the three. You will have crust, you will have mantle, you will have core. Okay, it looks like concentric balls. Concentric balls means like what you call as onion. Okay, there will be crust layer. If I remove crust layer, I will get mantle layer. If I remove mantle layer, I will get outer core. If I remove outer core, I will get inner core. Okay, can I say earth is also arranged similar to, okay, onions? Now you tell me, if I have a boundary, okay, if I have a boundary between core and mantle, if you take onion, okay, if you peel one layer, before you go to another layer, have you seen, like, you will have a small cover like structure, plastic like structure? Yes. If you remove one layer, you will get, can I say that acts as transition layer? Can I say that acts as transition layer? So you tell me, in transition layer, will it have similar wave movement or will it have different wave movements? In transition layer, will it have same or different? As it is different, different people have found it. Different people have found it. So they have called it as discontinuity. Remember, it is called as discontinuity. What is a discontinuity? In between crust and mantle, it is called as moho discontinuity. Discontinuity. It is called as moho discontinuity. Okay, in between mantle and core, we call it as Gutenberg discontinuity. Okay, we call it as Gutenberg discontinuity. In between inner core and outer core, we call it as Lehman discontinuity. In between inner core and outer core, we observe Lehman discontinuity. Yes, ma'am. Discontinuity means in that region, speed will be different. Okay. See, guys, in between asthenosphere and lower solid mantle, in between asthenosphere and lower solid mantle, we normally have what we call it as Rapiti discontinuity. And then, guys, there is something called as upper crust and lower crust. Okay, that upper crust and lower crust, they call it as Conrad discontinuity. This is not yet clear, guys. What exactly is that? It is not yet clear, but people normally say it is the junction where plates converge. Okay, the junction where plates converge, there will be some sort of discontinuity called as Conrad discontinuity. Guys, you see here, this one is known as lithosphere. Till 100 kilometer it is called as lithosphere. Till 2900 kilometer it is called as mesosphere, or I call it as pyrosphere. Pyrosphere. This is called as barysphere. So we have lithosphere, mesosphere or pyrosphere, barysphere. We have three spheres in this particular part. Yes. Yes. Yeah. Guys, can I will write and then we will take break, then you can draw. Okay? Everyone. You write heading as, you write subheading, analyzing Earth's interior, analyzing Earth's interior with seismic waves. With seismic waves. From the shadow zone of P and S waves, it is clear that inside the earth, density varies, and that is the reason for curving of waves. That is the reason for curving of waves. Second point. Beyond 2900 kilometers or 105 degree, P waves slow down and S waves disappear. Indicating shall I move? Indicating there is liquid outer core. Next point. Body waves travel faster in 5 kilometer thick oceanic crust compared to 35 kilometer thick continental crust. Compared to 35 kilometer thick continental crust, indicating that oceanic is denser compared to continental. Next is, beyond the crust, speed of P and S waves increase till 100 kilometers, indicating that upper solid mantle is denser. Upper solid mantle is denser. Can I move? You should be fast, guys. I'm writing. Beyond 100 kilometers, P waves and S waves slow down, indicating there is semi-solid layer like asthenosphere. This proves convection current. Do you all agree? This proves convection current theory. Next, beyond 600 kilometers, body waves speed increases till 2900 kilometers, indicating that there is solid lower mantle. Beyond 2900 kilometers or 105 degree, P waves slow down and S waves disappear, indicating what does it indicate? indicating liquid medium. Indicating liquid medium. Beyond 5,100 kilometers, P waves will travel at highest speed, indicating that inner core is made up of highest density. Then is lithosphere. Crust plus upper solid mantle. Mesosphere or pyrosphere. Mesosphere is there in atmosphere also. It is there here also, which includes asthenosphere and lower solid mantle. Third, barysphere. Inner core and outer core. Inner core and outer core. Done? Discontinuities. Conrad, they use the term upper crust and lower crust. Guys, there is nothing called upper crust and lower crust, but it is the junction of continent and ocean. Moho, Mohorovic. Okay, Sushmita, I actually saw this. Conrad or Conrad. Moho, crust and mantle. Third, rapidity. Upper mantle and lower mantle. Gutenberg. Mantle and core. Layman. Inner core and outer core. Because this is what we have. This is what we have. Shall I move? Can you please draw this, guys? Draw this and take. Hayat, new things are coming, don't worry. Okay. We'll meet at 7, guys. Please draw properly and then take break. everyone. Okay, guys, volcanoes are left, guys. Volcanoes slides are there in next session. So today I'll start with exogenetic forces. Exogenetic forces. Okay. Now, when we talk about exogenetic forces, these forces occur outside the Earth surface. These forces occur outside the Earth surface. They are divided into three, guys. One is called as weathering. Ma'am, that's what we saw, ma'am. Crust, mantle, and core. Nothing more beyond that. Weathering, mass movement, and erosions. Weathering basically means, guys, breakdown of rocks. Breakdown of rocks in situ. Okay, in situ means in that place. In that place. Breakdown of rocks in that place is called as weathering. Okay. Mass movement basically means when rocks move down due to gravity. Okay, guys, you see, I have a rock here. In this place itself, if rocks break down into smaller particles, then I call it as mass movement. Sorry, then I call it as weathering. In this place itself, if a rock is broken down into smaller particles, we call it as weathering. Now I have a mountain. On this mountain, particles are moving down due to gravity. If particles move down due to gravity, it is called as mass movement. Erosion. Okay. If there is transportation, let us say rock is transported, and during the transportation, if there is breakdown, okay, during the transportation, if there is breakdown, that is breakdown of rocks ex situ. Breakdown of rocks ex situ. This ex situ means away from that place. For example, I have a rock. Okay, river is flowing through it. Now what the river did? river carried those big rocks along with it. And when the river is carrying it, the rock will hit, keep on hitting, and then break down into smaller particles. You see, guys, I have a rock here, okay? Let me say this is a rock. I have a rock here. In this place only, if the rock breaks down into smaller particles, it is called as weathering. Okay, because of wind, because of water, if this is transported, and if it is broken down somewhere else, then it is called as what? Erosion. Okay, so when breakdown occurs in that place, it is called as weathering. If breakdown occurs away from the place where rock is there, it is called as erosion. Okay, I have weathering, I have erosion. Now, everyone, erosion is mostly done by different agents. For example, rivers may carry. Okay, so when rivers do erosion, it will create landforms called as fluvial landforms. What is a landform? Waterfalls is a landform. Delta is a landform. Okay, whenever rivers break the rocks and deposit them, they will create few features. Those features are called as what? Fluvial landforms. When glaciers create landforms, it is called as glacial landforms. It is called as glacial landforms. When sea waves create landforms, it is called as coastal landforms. When underground water create landforms, it is called as karst landforms. Okay, underground water, when it create any landform, it is called as karst landform. If wind acts, then it is called as Aeolian landform. Whenever wind form anything, it is called as Aeolian. Wind deposited landforms are called as Aeolian landforms. Whenever river deposits, it is called as fluvial. Nothing much. Yes. Now, we will start with weathering this. Weathering. Okay. What is weathering? It is disintegration. It is disintegration and decomposition. Disintegration and decomposition of rocks in situ. Okay, see guys, disintegration. Integration means joining, disintegration means breaking down. Okay, decomposition. Composition means it will come together. Decomposition, you are trying to remove it. Okay, So remove the integrity of the rocks. Now, there are three types of weatherings, guys. One is called as physical or mechanical weathering. Physical weathering or mechanical weathering. Okay, guys. So remember, whenever rocks break down without changing their chemical composition, okay, rock is breaking down, but its chemical composition has not changed, then it is called as physical weathering or mechanical weathering. Okay, so here, everyone, physical or mechanical weathering, you have to write when there is breakdown of rocks, breakdown or disintegration of rocks, in situ, without change in chemical composition, change in chemical composition is called physical weathering. See guys, it should break down without chemical change, then it is called as physical weathering. Okay, I'll move guys. You'll have types. First one, freeze, thaw or frost shattering. We call freeze thaw weathering. Yes, ma'am. This is types of physical weathering. Freeze thaw weathering or frost shattering. Okay. See, guys, if I consider temperate region, okay, temperate region, summer will be hot. So what will be there in summer? Water will be there. Winter will be cold. What will be there in winter? Ice will be there. Now you see, let me say I have a rock. Okay. Now inside the rock, water is getting accumulated. Due to rainfall, water is getting accumulated. Now what happens? During winter season, this water gets converted into ice. Summer season, rock, water got accumulated. Winter season, rock, ice is there. Guys, remember, water is the only liquid which expands when it is cooled. So basically what happens, there will be pressure of ice on the rock. You tell me, if there is pressure on the rock, is there a possibility that the rock will crack down? Is because of the pressure, rock will break down. As rock will crack down, the rock will form like this. Now you tell me, in this thing, did you observe that rock is broken down in that place itself? It did not get transported and it did not had chemical change. Yes, ma'am. Yes, Anjali. Yes. Everyone, did you draw? Aditya, please learn that, Aditya. It's a very basic thing. Okay. Water expands because in between you get air particles. Within the ice, air particles will be there. That's why it expands. And that is the reason ice will float on water. Ice is in solid form. Okay. It will float on water rather than going down. That is mainly because within the ice, whenever water becomes ice, in between that, some what you call as air particles will be filled. That's the problem. Pores. Did you draw this? Completed? Yes. Second, insolation weathering. Insolation weathering. So you have a rock. Let us talk about desert areas. Okay. During daytime. Yes, can I say as sun's rays penetrate into the rock, can we say that rock expands? As sun's rays penetrate into the rocks, can we say that rock expands? Yes. Now you tell, in the night, can I say as sun's rays will not be there, that part of the rock contracts? So can I say during day it expands, during night it contracts? So alternatively, when it expands and contracts, when it expands and contracts, Can I say it will develop cracks, guys? Expansion, contraction. Then what is going to happen? The new layer will be exposed. This part will be weathered. Because of high temperature, that is when sun's rays penetrate, within the rock, wherever air particles are there, those air particles expand. So there will be expansion, contraction, is very thin layer. So over a period of time, that particular layer gets cracked. In arid areas, arid means desert areas. In arid areas, we normally observe that rocks would expand during day and contract during night. And contract during night. Due to this, cracks will be developed. Due to this, cracks will be developed. Here, contraction is not frost thawing. This is frost. Basically, comes in temperate region. Arid region we do not have. Guys, everyone see here. Check this properly. Okay. Now, I will put pressure on this, guys. Okay. I'll put extreme pressure on this. Okay. Suddenly, I will release. If I release suddenly, can you see some layers of the book is getting opened slowly? You see here, everyone? I will press it. If I release, can you see some gaps develop slowly in these areas? You see? Can you see slowly it is opening? Everyone? So normally what happens, guys? Rocks inside. Okay. So what people normally say, third, expansion due to unloading. Expansion due to unloading. Okay. What exactly is this, guys? Expansion due to unloading. You see, inside the earth, you may have a very big rock. Okay. And this is covered by some sediments. Now what has happened? On this rock, lot of pressure is there, okay? On this rock, lot of pressure is there. Now what happens? Let us say the above part is removed. The above part is removed. So what is going to happen? All of a sudden, there will be development of cracks. All of a sudden, there will be development of cracks. Guess you tell me, if this layer is removed, okay, I'm removed by erosion. Removed by erosion. Erosion means, can I say wind erosion and all, will it remove? So removed by erosion. Okay, you tell me guys, now if this layer is removed, can I say the next layer gets expanded? Can I say one layer after the other, it keeps on expanding? 6. When rocks inside the earth is under high pressure and when the above layers are removed due to erosion, then the rock would expand suddenly. As the rock expands, it would develop cracks. It would develop cracks. Full stop. Once one layer is removed, then once one layer is removed, then shall I move? Then other layers also expand and break, called as exfoliation. Exfoliation. Guys, exfoliation basically means layer after layer will be removed. Scrubbing is different. Exfoliation means layer after layer. Onion peeling we call. Like, layer after layer will be removed. Yes. and it will occur. Can you tell me which rocks will have layer after layer? Which type of rocks will have layers? Sedimentary. Good. Next, fourth type. Yeah, Vinod, almost same. Salt crystal growth. See guys, let us say you're near the ocean, okay? Near the ocean, the rocks had some gaps. Ocean water entered into it, okay? Then, due to evaporation, water is removed, but salt crystals are left behind, okay? I repeat, near the ocean, you have some rocks, and in that rock, some gaps were there. In that gaps, salt water entered. Water gets evaporated, salt crystals are left behind. Now, due to solar insolation, the salt crystals may expand and contract. The salt crystals may expand and contract. As they expand and contract, we normally observe that the rocks will keep on making holes. I will show you this. That is not chemically precipitated. You see here, guys, this is freeze thaw or frost shattering. Here, water is becoming ice and exerting pressure. Here, you can see expansion due to unloading. Yes, Sushmit, it will be shared with you, don't worry. Insolation weathering. Can you see here? This is your salt crystal growth. Okay. This is your salt crystal growth. Can you see some gaps are increasing here? So below salt crystal growth, you can write near coastal areas, ocean water, no need to draw, ocean water enter into cracks or joints, and we observe that as water is evaporated, salts are left behind and they expand and contract alternatively and exert pressure on the rocks. Everyone done? Six. Next you have chemical weathering. What exactly is chemical weathering? Chemical weathering basically means there will be, you can see the term here, decomposition of the rock. Okay, there will be decomposition of the rock. Now here you can write chemical weathering processes. Below that you can write oxidation or reduction. Oxidation or reduction. You can write due to rust. Yes, you tell me, due to rust. Can I say ferrous minerals? Ferrous minerals will become ferrous oxide and it is easy to erode. Do you agree? Or easy to weather. Can I say once it is rust, easy to break? Once it is rusted, easy to break? That's what you will observe in this. That's what you will observe in this. Shall I move? See this. Next principle, you write carbonation. 6. Limestone is there. Okay, limestone is there. You might have seen in the house also, anywhere at least you would have seen, where washrooms are above and if leakage is there, that particular area or that entire area, like you will see something will be dripping from that particular part, right? It keeps dripping from that particular part. Now the same thing occurs here. What is it? Acid rain. Okay, acid rain or carbonic acid dissolves limestone to form calcium bicarbonate. Okay, acid rain dissolves limestone to form calcium bicarbonate. Remember guys, once calcium bicarbonate is formed, it is easy to break. Once calcium bicarbonate is formed, it is easy to break. Yes. Shall I move? No need to by heart pump. These are all basics. Like, you just need to write it. That's it. Last, you have biological weathering. Biological weathering. See guys, whenever living organism does two things. There can be disintegration also. There can be decomposition also. So if there is both disintegration and decomposition, then by living organisms, then it is called as biological activity. Sushmit, you need to write, Sushmit. Anything if you don't write, don't explain, you won't get marks. So guys, due to biological organisms or living organisms, if there is disintegration and decomposition, then it is called as biological weathering. See here. All these are normally done by living organisms. So you just need to write Biological weathering. Biological weathering. When living organisms are involved in when living organisms are involved in disintegration and decomposition of rocks, then it is biological weathering. Okay, guys, this will be asked for 10 marks, guys. This will be asked for 10 marks. You must be aware about it. Yes, Aditi. Next, guys, everyone. Mass movement. Mass movement or mass wasting. Mass movement or mass wasting. Okay. 6. What is this? Whenever denuded means broken down, denuded material would come down due to gravity, then it is mass movement. Is this word is very important for you. What is the word? Gravity. Due to gravity, if it comes down, then it is called as mass movement. Is basically look at this. Can you tell me, guys, first case, second case, where will you have mass movement, where you won't have mass movement? Okay. So in the first case, you see, guys, the rock will be sticking. We call stick force. We have slide force. Slide force. Here also you have stick force. You have slide force. Everyone, can I say in this case, stick force is greater than slide force, and here slide force is greater than stick force. Guys, whenever slide force is greater than stick force, we will observe mass movement. Okay, whenever slide force is more than stick force, we will have mass movement. Shall I move to the next one, guys? There are three types of mass movements, guys. One is called as slide. Yes, Sanjay. One is called as slide. Second one is called as fall or flow. Okay. Third one is called as creep or heave. Let me explain all the three. Okay. Slide, fall or flow, creep or heave. Everyone see here. When slope is like this, when upper part of the rock is behind and lower part is ahead, lower part is ahead, then it is called as a slide. Have you seen, even when you slide, everyone, even when you slide, imagine when you are sliding, the upper part would be behind and lower part would be ahead. Example for this is landslides. Okay. Now, fall or flow. Everyone think, when you fall, when you slip, okay, when you slip, normally upper part of the body will be ahead, lower part of the body will be behind. So, if I have slopes like this, normally upper part of the body, if it is ahead, lower part of the body is behind, normally what is going to happen? This will fall. We call it as rock fall. Rock fall. Let me give you other example. Everyone, I'll give you time to drop. Please check this. Please check this. I have water, guys. Okay. I have two layers of water. This is Earth surface. A layer, B layer. Okay. A layer is in contact with the land. A layer is in contact with the land. B layer is in contact with A layer. You see, A layer is in contact with Earth. B layer is in contact with A. Yes, can I say B layer will have less friction. Everyone, B layer will have less friction. A layer will have more friction. Correct, everyone? Why? Because A layer is in contact with the land. B layer is in contact with the water. Okay, everyone, now you think and tell. If B layer has less friction, A layer has more friction, which one will be faster, which one will be slower? Which one will be faster, which one will be slower? B will be fast. Everyone, the water will go like this. You see, water will go like this. Can you see B layer is ahead? B layer is ahead. A layer is behind. A layer is behind. Yes, this is called as flows. We give example of mud flow. We give example of mud flow. You see, you have slide, you have fall or flow, you have creep or heave, guys. Creep or heave. Okay. Everyone, just 2 minutes you draw this. I'll explain what is creep or heave. Okay. See guys, everyone, people who are not able to understand fall or flow, okay? You see here, Vinay, Aniket and all, you see here. This is the slope, guys, okay? Now I have my mobile. My mobile will go like this. My mobile will go like this. What is it called as? What is it called as? Is it slide or fall, guys? Can you tell? Slide. Can I say it is going backwards? Slide. Okay. Now, Aniket and Vinay, you see, you have like this. The mobile is like this. The mobile is like this. Can I say above part is ahead and below part is behind? Can I say the rock will fall down like this? Rock will fall down like this. Yes. Okay. That is called as fall. That is called as fall. Now, you tell me, I have a slide like this. Everyone check this. My hand is water, okay? One layer is flowing on the land. One layer is flowing on the land. Another layer is flowing on the hand. Okay, let me say hand is smooth. Box is having some variations. Okay, friction is more. Now when my hand is going on the rock, friction is more, so it will be slow. If another hand is moving on this less friction, movement is faster. So here you see, A layer is in contact with the land. So it will have more friction. B layer has less friction. Okay. Now, third one, what we have is creep or heave, guys. Okay. Everyone think and tell. Okay. Think and tell this problem. You see. See, guys. Let me say this is mud. This is mountain. This is mud. Now you tell mud got expanded. Mud got expanded due to sun's rays. See, in the mud, air will be there. Air will be heated. Air gets expanded. Now you tell, if mud expands, okay, will it go back or will it go downwards? Think and tell, if mud is expanded, will it go back or will it go down? What is going to happen? You tell me, if you fall, if you jump from a building, will building attract you or ground attract you? So what is going to happen? Same thing. What is going to happen here? Expansion, contraction. expansion, contraction, expansion, contraction. Can I say here there is some movement of the material? Everyone check this. Everyone check this. Okay. Now this is a slope. This is a pole. Okay. This is a pole. Now slowly it hits. Slowly it hits. Slowly it hits. Slowly it hits. Can I say over a period of time, what do you call as the pole which was like this started going down like this? Started going down like this? Has it bent? In mountains and all, you will normally observe that the pole and all would have bent. That is called as creep or heaves. So what is going to happen in this? If I have original surface, and if I have expanded surface, then what will happen? Expansion will occur, contraction will occur. Expansion will occur, contraction will occur. Expansion will occur, contraction. Expansion, contraction. Expansion, contraction. So here what is going to happen? This will be expansion. This will be contraction. Due to this, there will be movement. Yes, Parul and Aditi. When unconsolidated sediments are heated, they expand and contract alternatively. Due to this, there will be downward movement. There will be downward movement. Guys, mass movement questions won't come. The only question that comes in mass movement is what is the difference between landslides in Himalayas and Western Ghats? Most repeated one is always this only. Okay, so that we should try to see. No need, ma'am. Actually, these are all what we try to talk, but not required. Okay. Okay, guys. Tomorrow I will tell what is the difference between landslides in Himalayas and Western Ghats, and then I will talk about soils, guys. Okay. Once the soils is completed, I will try to teach you agriculture. You see, I know rainfall, I know soil. I will teach you agriculture. Then we will talk about physiography and oceanography. Thank you, guys. Okay, tomorrow is holiday. Fine.